Hello everyone. My name is Mershad Amini. I'm a new postdoc scholar at Oregon State University. I joined working with Dan and Andre. I joined the research program in August 2 months ago, a little more, maybe 2 months and 10 days. And this is the first official presentation in NIST and the INCORE project. I'm very happy to share some part of my result and during this 2 months. So the presentation is about the demonstration of CGE analysis using Seaide Testbed for direct and indirect loss and risk. And this is a research in progress. I cannot go to the next slide. Okay. So everyone, that's the NIST INCORE flowchart. So the today talk is about to get a focus on the relationship between the hazard model, damage to the physical infrastructure, functionality, and the definition of the input that goes to the CGE model, and has a discussion of the direct and indirect economic and social losses for the Seaide testbed. As a quick introduction, I'm sure everyone are familiar with the Seaide. Seaide is a multi-hazard testbed for damage, loss, and recovery for earthquake, tsunami, and combined hazard. In the INCORE, we have earthquake and tsunami hazard for 7 recurrence interval, 100 to 10,000 year. In terms of the built environment, we have a good information about the buildings, electrical power network, transportation, and water supply. About the socio-economic environments, just as a quick summary, the population based on the 2018 data is 6,795, and we have information about the median income, and the primary industry is travel and tourism in the Seaide. Also in the figure, you can see the spatial distribution of the building in terms of the building type, reinforced concrete, and a wood frame. So as a quick review of the goals and objectives, the project is going to investigate the vulnerability of different economic sectors to natural hazard in the community using the CGE model. Evaluate the impact of the different hazard on the economy in terms of the direct and indirect loss, such as a capital loss, which is categorized as a direct loss, and the total employment and domestic supply in terms of the indirect loss. Study the effect of multi-hazard on the economic metrics, earthquake, tsunami, and the combined. And one of the important one is the research we are doing, performing a sensitivity analysis to understand the effect of building functionality, the definition on the capital shock, and the output from the CGE model. And finally, just a quick review to discuss the extent of direct and indirect loss and associated risk for the post-disaster communities. So in the CGE modeling, the INCORE, we have some define the input, which include the capital stock loss, which, as I mentioned, is in kind of the direct damage and loss, social accounting matrix, capital matrix, employment, job, and household data. So just to everyone on the same page, so capital stock functioning is defined for each individual building as the functionality probability multiplied by value of the building, which can be in terms of the dollars or percentage. And the functionality probability comes from the damage model and the Monte Carlo simulation from the INCORE. And also the important key is how to define the functionality in the process. And once you have the capital stock functioning, 1 minus capital stock function it gives you the capital stock loss, which in the next slide, sometimes we just switch from capital loss to capital functioning. So in the Seaide, there are 10 different economic sectors, which are divided into 3 regions based on the distance from the ocean and the coast. So for the housing, we have around 2,800 billing, the service sector 450, and it goes down to retail, restaurant and accommodation, and healthcare, construction, manufacture, agriculture, and utility. And this shows a kind of the definition of the zone and just example of the service sector. The figure on the left side, as you can see, the region is divided by two creeks here. We can point with my mouse. So the left side, the green is zone 1, the middle zone 2, and the inland area is zone 3. And figure on the right side shows the example, the distribution of the service sector 1, 2, 3. If I go to the previous slide, for each sectors, we have 1, 2, 3 based on the spatial distribution. Just as a example of the Jupyter network for doing capital shock analysis for earthquake, tsunami, and the combined damage. So one thing which is worth mentioning is we need to define a building to sectors ID, which kind of map the geo ID from the building to a specific sector. And that's kind of the critical information. And also the shock analysis get the input from failure probability comes from the Monte Carlo simulation. And this figure shows an example of the capital shock analysis in terms of the direct loss. This example is for 250-year earthquake. And as the first scenario is the building is not functional if it's located in damage stage 1, 2, and 3. The figure on the left shows kind of the aggregated result for sector. Each sector, we have the capital stock, which the summation of the building values multiplied by functionality, probability of functionality gives you the capital stock functioning, the dollar value, and then it can be converted to the percentage, which gives off the capital stock functioning. So for here, as example, the housing sector, we have 50% functioning for that sector. And the figure on the right, you can see the breakdown of the result. So for housing sector 1, 2, and 3, which is kind of the breakdown based on the spatial distribution. 1 is the ocean front, 2 the middle, and 3 the housing in the inland. So after having the capital shock result, we go to the CGE modeling. We need to define more inputs. I just mentioned 2 of them, which is interesting to me. The first one is the social accounting matrix. It shows define the interaction between the firms, household, and government. And also, for example, the employment table, which is the contain the data for commercial sector employment. And from here at the top is the input for the CGE modeling, and you assign the sector shocks as a second category of the input for the CGE modeling to run the model and get the indirect result. And this is an example of the CGE output. So this output includes the total employment, domestic supply, real household income, and the local property and accommodation taxes. You can see on the right table, so for each of them, we have the amount of the change, which is the unit is million of dollar, and also the percentage. For the real household income, we have a breakdown of 5 groups, which we can see they are categorized based on the annual income. For example, HH1 is the income less than $15,000 a year, till the highest one, HH5, which is the income more than $10,000 a year. And just a quick mention that the result is for 250-year earthquake, and that the same scenario for the building functionality. In the Seaide, because we have the hazard based on different recurrence interval, we can have the capital shock loss for different hazards and different sections. For example, the left figure shows the distribution of different sectors. For earthquake, 100, 250, and 500-year return period or recurrence interval. The middle the same for tsunami, and the right is the for combined damage. And you can see for each column, we have the highlight value, which shows the maximum loss. And by the way, so this is the capital shock loss, which 1 minus functionality, which is 0 is no loss to the sectors, and 1 shows the total loss. So one interesting thing that we came up with the research is, for example, for earthquake 500 year, most of the sections we lost 55 or 60% of the sector during to that extreme event. And if you go anything return interval above 500, for example, I think for 1000 it goes maybe to 80% of the loss for each sectors. And the CGE modeling in the in-core now is not capable of get a very large extreme shock. And the CGE, as a part of the future study, which was mentioned at the end of the presentation, we need to modify the model based on our meeting with Harvey and his postdoc scholars. And one of the keys is we need to adjust the elasticity factor in the CGE modeling in order to put a very large shock to the model. So that's why we cut the current result to a return period of 500. And for tsunami, as you can see, for 100 and 250, so there are no inundation in the seaside. And for example, the maximum of capital loss is 2 and kind of the 3%. And from 500, it starts and goes to 36%, the maximum, which is for housing sector 1, which is near the ocean front. And also you have the comparison for combined hazards. This is a comparison for capital shock loss for housing sector. The row on top is for zone 1 ocean front, the middle blue one is for zone 2 middle, and zone 3 inland. And it's the column wise, you have the earthquake, tsunami, and the combined damage. As you can see, for zone 1, the earthquake is kind of you have similar result for zone 1, 2, and 3. For example, for return interval 250, you are near 50%, less than 50% loss for that sector. For tsunami, for the first two recurrence interval, 100 and 250, we don't have any significant capital stock loss. And it started from 500. As you can see, as you go from zone 1 to 3, it goes to the inland, the maximum value gonna decrease because you have the further distance from the coast, and the tsunami hazard is gonna decrease. And also for the combined result, which usually it's dominant with the earthquake, you can see the comparison for the different zone. And also this comparison can be developed for each sector. And I didn't present all of them because for the sake of time and brevity. So this one was just for housing sector. We go for the indirect loss, the CGE result for employment on the left figure. We have the total employment change in terms of the percentage for earthquake, different return period, and the right figure shows the domestic supply change. It was just the example that we have comparison for indirect CGE results for different hazard, earthquake, tsunami, and combined. So, and also another important thing is this figure shows the indirect losses from CGE analysis. The column on top, it shows the total employment change due to the earthquake, the middle ones due to the tsunami, and the bottom, the combined damage. As you can see, in addition to the percentage, we can develop the risk curve, which is the amount of change multiplied by probability of occurrence. As you can see, for different hazard, earthquake, tsunami, and combined, the maximum associated risk is going to change. So for example, for earthquakes, it's 250, and for tsunami, it goes to the 500, and for combined, back to 250, but with the different value. And so it was just for the employments. We can have develop all the information, the same information for domestic supply or tax or household income, which I haven't presented here for the sake of time. Then another example for household income, the same situation, that the household income percentage for earthquake, tsunami, and combined and associated risk curves with the maximum risk and also the values is going to changing correspondingly. And for example, here the tsunami, the value of the risk is much less compared to the earthquake and the combined, which is matched with the idea of that we didn't have any capital shock result as input to the CGE modeling. So I think the next part, which is very important, is doing the sensitivity analysis to investigate the effect of functionality, probability of building on the CGE result. So, I mean, from the references and the literature review, the definition of the functionality in CGE model is residential structure are livable and commercial structure are still usable by firms to produce and sell their goods. So here we have 4 different damage states, a slide to complete. And I just investigate 2 different scenarios. The first one is building is not functional, damage state 1 through 3, 1, 2, and 3, which we have seen some results in previous slides. And the scenario 2 is building is not functional if located in only damage state 2 and 3. Before going to see the capital stock shock and CGE output, just a comparison between the hazard fragility curves. The left figure shows for earthquake, and the right figure shows for the tsunami structural fragility curves. As you can see, for earthquake, we have very detailed information from different damage states, non, moderate, extensive, and complete. But for tsunami, it's kind of they are overlap, and the difference is kind of distinguished between non or insignificant and the complete. So based on that, we predict that this 2 scenario is not going to be sensitive for for tsunami because we don't have that detailed information. So, so this figure shows the capital shock loss to housing sector for different scenario 1 and 2. The top row is zone 1 oceanfront, middle, and the inland. And the red is scenario 1, which is damage state 1, 2, and 3 as a non-functional damage state, and scenario 2 is just damage 2 and 3. As you can see, for all 3 zone, earthquake definition of the damage states affect the result in terms of the capital shock loss, but for the tsunami, it's not sensitive. And for the combined, again, it's sensitive because the earthquake dominates the result in kind of the Seaide for 3 recurrence interval. We have the same situation for total employment change, which is the output of the CGE modeling. The left one is the total employment change in terms of percentage for earthquake, scenario 1 and 2, tsunami, and the combined. As you can see, the sensitivity of the CGE modeling for damage and functionality definition for earthquake is significant, but for tsunami, doesn't change that much. So as a quick review of the conclusion, so the vulnerability of economic sector are dependent on type of the hazard and recurrence interval. The amount of the loss and risk are sensitive to the type of hazard, which the highest risk are associated with the 250 and 500 year earthquake and tsunami event. And the risk and associated recurrence interval changes considering the combined effect of the earthquake and tsunami. And the definition of the building functionality can significantly affect the CGE result, particularly for earthquake hazard considering using the hazardous fragility curves. And finally, once adjusted and the model is tuned, the result in terms of the direct and indirect loss and associated risk can be used by community decision and policy makers. As a future works, we are aiming to modify the CGE model to extend the work for damage and loss with a return interval larger than 500, which kind of defined as extreme event. Working on integrating with INCORE for January release, and also the Jupyter notebook will be available by January release too. And this is just a list of the references that I used for this presentation and the research. And that's the end of the presentation. And thank you for everyone. I open to question and the discussion. Thank you.